And let me go over to here and here. Okay. And first of all, it's going to be a real quick review. I think. Okay. So I think we're not going to go in depth instead of the what exactly will be tested. Okay. But I think we want to give a more like direction what kind of problem we'll be testing based on the uh, coverage we have so far for the second quarter of it. So first problem is the irregular section, right? Okay. Specifically, I think we can talk about section with holes and T-beam, okay, and I-beam, okay. And also, in particular, if we have a continuous beam, okay, something like this, all right, we need you to determine the flange width, okay, and we also need you to determine the moment capacity, right, give you the rebar position, okay, something we can discuss here, okay, is that you need to, first of all, find out the compressive zone, of course. And for T-beam and I-beam, essentially is to find out whether the compressive zone is smaller than HF or the compressive zone is bigger than HF. Okay, that's something we need to find out first. All right. So once you determine that, you can find your compressive zone and tension zone and figure out the tension force in the reinforcement and find the moment capacity there. Okay, so that's the part you need to review on the irregular section. All right, so on the one-way slab, okay, on the one-way slab, now you will see a section like this. Okay, and you need to have different spans, right? So we have, this is the one span direction, and we have different span lengths, and you have the other span direction. Okay, so as we said, it's one-way slab, so it only consider one-way bending. Okay, only consider one-way bending. All right, so this is the unit strip. Center of inches. Okay, and make sure you understand when we design the one-way slab, right? So we usually give you a cross section like this. Okay, and we need you to determine the moment coefficient, and of course, this is looking from the cross section here. Okay, we need you to determine the moment coefficient, right, using ACI. And to do that, okay, moment coefficient in ACI. To do that, we need to decide whether, I mean, it is integrated support or is this a simply supported case? Which case, right? And this will determine whether you can use that number as 24, or this minus 16, etc., so on and so forth, right? So these are something we need you to understand. The other thing is that there's ACI moment coefficient requirement. Okay, so what type of conditions you can use the moment coefficient? So if you recall from the previous notes, there are actually five requirements. Okay, list the field, for example, Ln one has to be within Ln two, about 20% difference. Okay, cannot be too much. And there's 1.2 dead plus 1.6 live, cannot be exceeding 1.4 dead. This is weight limitation, constraint, something like that. Okay, and there are others, and please go back and review. All right, we probably need to provide a reason why you can use the moment coefficient. Okay, so once we figure out a moment, right, and we'll tell you the the self-weight and the distributed load, so you can calculate omega u, and there's ln squared, and you need to determine which ln to use. If it's at the junction, you need to consider the ln left, the ln right. You need to consider both sides of it. Okay, and to use the average. Okay, use the average length. Right, so that is something you need to consider to get the moment going. Right, now once you have the moment, things become easier. It's just a one-way slab, and the bottom is the bar. This is HF, which is the height of the slab, and we have a procedure on how you calculate the reinforcement. And don't forget that reinforcement AS is per 12 inches. Okay, you need to divide that by 12 inches to get a average reinforcement area. Okay, so it's going to be very straightforward. You wouldn't see like two-way direction, just one-way direction, and this is how you're going to calculate the reinforcement for it. Okay, then moving on, we talk about shear. We talk about shear reinforcement. All right, so for the shear reinforcement, there are VC, which is the concrete contribution, VS from steel, and we need you to understand in the shear diagram, for example, if I have a cantilever beam, or if I have a simply supported beam, what the shear diagram looks like. Okay, so for a distributed, simply supported beam, right? So I have a shear like this. Okay, for cantilever beam, I have a shear like this. Right, so the shear diagram is different. And based on the shear diagram, right, we need to know where is my VC contribution, basically half VC, and you have different zones for sterile spacings, right? There are 1, 2, 3. Remember, go back and take a look at that. So this is going to be the shear reinforcement. It's mainly for design, okay? Mainly for design. And the last but not least, right, we have talked about the bending or serviceability, right? Serviceability. Right? So for the serviceability, we mainly consider the gross moment inertia, the crack moment of inertia, IGICR. And for IG, you have a cross section like this, and this is the bar, right? And how do you convert the bar into a strip and do the whole moment inertia? For cracked, there are cracked region, and there's a bar, and you can convert that into strips. And this is, don't forget, n minus 1 AS, n being the modulus ratio. Okay, and this is n AS. Okay, why? Because I have a crack section right here. Okay, and not only for regular sections, but also pay attention to T-beam. If I have a T section, how are you going to do it? Okay, if I have an I section, how are you going to do it? Okay, just word of advice, right? You remember there's a KD, right? We talk about that. Still can use it to find KD, assuming it's just a big old rectangular section. Okay, we talk about that in the lecture, so go back and take a look at it, how we design it for it. Okay, all right. So, ladies and gentlemen, this is it. This is 4 types of problem you'll be tested on. Okay, so as I said, it's going to be very short, and I mainly here for any questions. Okay, so questions from the audience? Anything for me, guys? Oh, quiet. Are we good? Okay. All right. So these just the general type of problem you're going to encounter. So if you're running out of time, you can go back in the specific lectures, notes, and review those and see how we solve these problems. Okay. All right. All right. Well, it's very short. I understand that just very few problems that you have to work with. It's only 1 hour, so I don't think it's that challenging. But if you have more questions, I can answer them tomorrow morning as well. Okay. All right. Adam, you have any question?
Nope.
Okay. All right. So I'm going to stop right here, and you are welcome to stay behind for any other questions. If not, well, this is all we have for the exam. All right. It's pretty short. Okay. So let me stop sharing and ready for any questions you have. Okay.
Dr. Wu,
Yes, sir.
will you post this recording on Canvas or on YouTube, or where will you post it?
I often post this on YouTube.
Okay.
Uh-huh.
Okay, thanks.
Yep, no problem.
Thank
Anything
you.
else? Anything else? Okay. Let me see. Noah, did you write all these problems down, specifically? I'll upload the notes as well, but these are really simple problems. So do you have any questions? And I mean, did you find all the previous lectures on YouTube? Noah, it's still there? Okay, well, I guess I lost Noah. All right, well, since nobody's still here, so I'm just gonna stop recording and I talk to you guys tomorrow, okay? All right.